is Joel Shane Brown, welcoming you to the Bigger Picture Extreme Weather Breakdown, Save the Impossible Dream. I want to thank you for showing up, and I want to just say shortly that I was educated here in the state of Michigan, got my Bachelor of Arts degree, Juris Doctor degree, practiced law, went into business, retired, got certified by Al Gore's Climate Reality Project, and I am now in their leadership corps speaking on climate change. So before I get started, I do want to say thank you to those who have been kind enough to send me their comments, been encouraging. I do get one particular question I want to address right up front before we get started. How should I decide what I should do to get involved? And here's what I suggest. I say to them, you have to make an assessment of what brings you joy, what gives you satisfaction and delight. You figure that out first and see what fits into doing the work of climate change, climate justice. What are you good at is about your skills, about your resources, and this is an important consideration because you're going to be spending time doing this. You want to have some enthusiasm in doing it. This can be challenging work. You need to have staying power, and you need to know that you're bringing something. It'll also help you pick the kind of group that you're going to be joining in to work as part of a community. You don't want to be doing this alone. It's not going to be effective. So I thank Ayanna Johnson for this diagram. So here's the planet. We'll get started now. We always look at it from this standpoint because this is a unified organic living system. And when I say that, I mean you treat it like it's a living thing. It helps you have a better idea about having a stewardship about the planet as opposed to just exploiting it. And you need to have the right attitude about this planet because we've been treating it like a sewer for too long. And we need to balance this idea with treating it with more care, kindness, because we are destroying it, we're going to destroy ourselves. The study of ecology starts with looking at the planet as a organic living system that has ocean, land, it has atmosphere, it has what they call the cryosphere. You can see at the bottom there the snowy, icy ice caps. That's a ecological system called an ecosystem. The geosphere is the environment. The other part is biosphere and life. That's the species. That's everything that lives, including plants, including grass, including trees, the animals, mankind, the mammals, reptiles, fish, marine life, birds. Whatever it is, a species has a life cycle and it has the challenge of living and adapting to the changes on the earth. And we are in a historical moment. We have dramatic climatic changes going on that are not going to change in your lifetime, probably. And it's going to be a challenge to get this thing slowed down so that we can have more time to have a chance to get it stopped. Slowing down is for sure going to be a certainty to be a lot less hellish and make things better longer. So that's an assurance. Whether we've got enough time and enough effectiveness to make this adaptation and stop the change in climate weather, that's an open question. We have ecosystems. Ecosystems are specific, and here's a picture of about 14 of them around the world. And we've got, there's specific geographical areas with a complex network of life, community of living organisms like plants, animals, microbes. They interact with their physical environment that is living and non-living, And so they treat these as critical because this is where the species live. And they live in there, and if these ecosystems break down, deteriorate, go into what's called a climate tipping point, where they accelerate and basically either collapse or die off, then that affects the other ecosystems. Now, when it comes to ecosystems, when it comes to the species, when it comes to the parts of the environment, we have scientists studying all of these things individually, and we look at them more comprehensively, like ecology kind of takes more of an integrated approach. I want you to understand what the scientific method is. It's a method that is being used to accumulate and give us better perception and understanding of what's going on. It goes beyond just perception and the eye, what the eye can see. It does a lot about what's invisible, where there's differences that we can't otherwise perceive. And it's important to understand the method is to identify a problem or a question, do research and observation, create a hypothesis, which is a question. They do experiments. They create experiments that can be repeated and either confirm by other people, confirm their work, or it gets challenged. They collect and analyze results. They come to conclusions. They communicate this to their community. Anybody can read it. And it becomes, you can challenge it. They're part of a communication process. This is the scientific method. So I want you to understand that with microscopes and telescopes and sensors, we can see all kinds of things that we can't see, and it's critical in climate change. Let's say something that's visible in terms of pollution, because part of what's doing this in climate change is we're polluting and affecting the transfer of heat. And we're baking, so to speak. So I want you to understand, the first thing that we know from history, going back 250 years, with burning coal, we've discovered that coal can be used for heating and energy. And here's the soot. Makes it possible to see just what this pollution is. And there's all kinds of particulates, and you know about 10 million people a year just from the pollution die from that. And there are plastics. So that's pollution number one. It's a killer, but it's dwarfed by what we've got now. Here comes a whole other order of pollution. We burn it, and here is a refining plant. Now I want you to understand, in this particular form of emission, we're talking about 25% of all the emissions in the entire world come from the making of it. Just the making of it. It's terribly inefficient. And when it finally gets to you, you're going to have, you get the gallon of gas, and 70% of your burning of it in your car goes up as more emission. So we got 30% use and 25% of all the emissions in the world, plus all the transportation in the world, represents 50% of all the emissions in the world. So we have excess emissions of carbon dioxide and methane and nitrous oxide, which comes off of the burning of these fossil fuels. Yes. So you can see some smoking stuff coming off, but there's massive amounts of carbon, methane, and nitrous oxide. That's the stuff that carbon breaks down into molecules. And these molecules are called greenhouse gas carbon emissions. All of them are based on carbon, burning of it, but they have different potency. The difference is 1 pound of carbon is kind of the base. There's more carbon dioxide. You can see the pie chart there, 80%. 80 times worse. 1 pound of methane is 80 times worse. Would you believe it? That's based on a 20-year period. Now, the 20-year period, the methane is dropping out, but based on 100 years, we're looking at 30 times pound for pound. And nitrous oxide, 275 times worse pound for pound than carbon dioxide. That's 6% of all the emissions. Comes water vapor. It too is a greenhouse gas. And what's a greenhouse gas? It goes up in the atmosphere, and when the sunlight comes in and the heat starts to leave, it holds in a portion of the heat, and we bake in it. It remits it right back down to Earth. Take a look at this. We went along from 1800, we were using this fuel, very low usage amounts, and then bang, 1900, particularly post-World War II, 1945, look what happened in terms of the consumption of gas, oil, and coal in the world. It's skyrocketed. It's come to a point where it's unsustainable. And look at what we have in terms of the parts per million there. Starting around 1950, here's what we have from 1950, 1960. The Goldilocks amount was naturally would be 280 parts per million of carbon dioxide. And we'll look at this. We went from 1960 to 2024, it's 425 parts per million. So it's 50% more. It's never been this high in the history of civilization, 11,500 years. And we're into territory now. The heating of the planet, because of these greenhouse gas effects, is taking us beyond anywhere we've been before. So we're in the Holocene period, and every 1/10 of a degree that you are above this baseline is very, very dangerous. We're into a compounding. So let's see what happens here. 1960, you can see the global average of all the heating has been setting records every decade. Now, how much of this stuff is going up? We are using and burning 36 billion metric tons, 37, 38, and look at this. We just discovered with satellites, now look, that's carbon dioxide. When it comes to the methane, methane we discovered through the satellites with sensors that you couldn't see and that weren't being reported by the big oil companies, that and abandoned uncapped wells around the world. We have all kinds of methane. So that's on top of, we got greenhouse gas emissions that are skyrocketing. Here's what happens. So we talked about the drilling, the pumping, of transporting, the trucking, refining, the boating, the distribution, and the end use. So here's the greenhouse gas effect I want to talk about for a second. Here it is. Here's the atmosphere on the Earth. Looks like a pretty small area. It's 6,000 miles. But we have only 12 miles of the lowest range where we live. Is called the troposphere. And in that range is where all this carbon excess that doesn't get out is accumulating. And here's a picture of it. The greenhouse effect, the solar radiation comes in. It turns into infrared or heat. The Earth uses what it needs and can't absorb. That's called being a sink. And then the excess is either absorbed in the ocean, getting hotter, it's absorbed in the atmosphere, getting hotter, or it gets out. And the oceans are getting concentrated. And they're getting hotter and they heat slower than the atmosphere, but they also cool down slower. So we got a problem with those major pieces. What's the effect of the climate? Well, all of this heating is increasing the frequency, the size, the intensity, the destruction, and the cost of climate. Now, here's the biggest thing. We've got, besides losses, we have acceleration going on. So between 1960. And 2000, it was kind of going at a slow incremental amount. You saw the picture. But between 2000 to 2012, you may have noted that we had an acceleration. And we had a mega heat wave in Europe, 70,000 people died. 2010, a Russian mega heat wave died, 56,000. It motivated our having the 2015 international agreement, hey, we got to slow this thing down, we've got to stop it. And the weather keeps getting worse and compounding in mega, meaning out of control, wildfires, tornadoes, hurricanes, droughts, spreading, the heat domes, and cold domes, the melting ice caps and glaciers, the flooding, you know it. When you watch your news at night, imagine it being twice as bad because that's written in, that's unavoidable. It's how much worse are you going to have it? So what are the losses? What's really going on? Well, all this climate deterioration is causing ecosystem deterioration. The biodiversity losses, everything's are thinning out, they're dying out, or they're becoming close to extinct. Right now, the extinction levels are still just 100 times worse than previous historically, but we're going to be going into thousands of times. And we're having soil deterioration. All those top three, ecosystems, global biodiversity, everything that lives, and soil deterioration, about 20%. It's approximate. 20%, a little more than 20%. We're going to talk about these other next four, the trees, the coral reefs, et cetera, because it's worse in these cases, and I want you to be aware of it, because the acceleration didn't just happen from 2000 to 2012. It happened another acceleration between 2013 and 2022, and now we're getting to 23, 24, all times, and it's accelerating more. So what happens if it's not steady and it keeps going? Our time to get this thing under control, to slow it down, is contracting. So what is the loss? To the acceleration. I want you to understand now what's going on. The trees, you know about wildfires. All right, wildfires, you realize when you have a wildfire, it burns the trees. They can't drink in the carbon with photosynthesis and convert it into oxygen, which we breathe. It burns the trees, that's all carbon. It burns it and releases it. It makes the world hotter. It comes in and affects the trees some more, and there's a feedback loop. It gets worse. What happened here in 2023 in this acceleration, 24? Canada, look what happened to there. They had a 6% total forested area, severely damaged or totally wiped out forest fire. 6% of all the trees in Canada, part of the boreal forest. There's a picture of this acceleration problem. Coral reefs, coral reefs, 50% of all the coral reefs in just 50 years have died. They bleached out. The heating of the ocean has basically killed them. We are on a closing point of a tipping point where they will be, or they're all going to die out within about 35 years, 40 years. So we're not sure exactly when. We're going to find out. And at 25% of all the life in the coral reef, in marine, in the ocean, lives in coral reefs. And you know what? They're all going to go extinct. So that's that picture. If that isn't enough to disturb you, I want to tell you about the ocean. The ocean circulation is slowing down and basically distributes this. It impacts the weather. And it's a major factor in climate. And since the ocean is warming up, the last year or two, it's been all-time high. We're having an impact on climate change, if you haven't noticed. It's part of the spiking, they think. Well, they want more information, but I want you to understand what's going on. So part of this impacts this circulation, impacts the ocean currents. It impacts the the wind. And so that has major factor on every single ecosystem. Now, let's look at the Amazon rainforest. Look at the size of this ecosystem. 6 countries, huge in Brazil. It's a rainforest. They have a problem of drought. They have forest fires. They have deforestation, where they're cutting down trees to grow food. They're burning the trees. So what was and has always been a major sink draws in the carbon dioxide. The plants drink it in and breathe out. It's for the first time a net emitter over more than 1/2 of the entire ecosystem. There's more carbon emissions coming out than there is the drinking in. Now that's very dangerous right there, because you're losing, when that happens, the heat that's up in the atmosphere and the heating that's going on can't be absorbed, and we get an acceleration of the heating. Here's a picture from the satellite. You can see the 25% deterioration. There's some around the whole thing, but down there, particularly in that lower edge, there's droughts in there. This is a recent reassessment of the tipping point collapse. Tipping point, you know, the train's going up, it gets to the top of the hill, and just as it goes over the top, it's all of a sudden one little change, one little part, will all of a sudden it kicks it into a very fast acceleration. That's a tipping point. So what we want to say here is that, look at this. We're in 2025. You can see there that between 2025 to 2060, we're coming into a more, where tipping points are possible in practically every one of these. But come 2060, there's a thing where almost all of the ecosystems are going to be subject to high risk for tipping points. I want you to remember this 2060. This is important. Now listen, it's possible we're going to have a couple of 2, 3 tipping points between now and 2060. You realize that. But I'm saying practically all of them are at high risk. So look at this. The International Panel of Climate Change has stated, there's a very conservative international organization, that come 2055 and 2060, we're going to have 4.5, 5 degrees of Fahrenheit rise, 25 to 30% extinction of all life. So now instead of deterioration of 20%, we're going to have 25 to 30% extinction of everything, of life forms, and we're going to have thinning. Now that's a real acceleration, huh? And so what does that mean? That means more than 1 million species will be vulnerable to extinction at that time. How much farther do we have to go? Have we got 50% completed? Have we got 75% complete? What are our chances of getting this stopped? What are our chances with future technologies like quantum computing, nuclear fusion, carbon capture? And here's a big assessment at the very same time. Are we in the 6th mass extinction? Here's a chart of 500 million years. And during the last 500 million years ago, we've had 5 mass extinctions events. And there are experts who are already predicting that we may be in a 6th mass extinction event that could be unfolding between now and the next 100 years. And in this, we're talking about 75 to 80% of all life could go extinct. And this might include mankind. So the story is if we go back to the 5th one, the one furthest to the right, that was 70 million years ago since we had a mass extinction event. And in that era, that was the end of the dinosaurs. So mankind's been around for 300,000 years, primitive man, civilization for 11,500 years, and now through our own created problem, we have coming potentially 25 to 30% extinction, and will it grow and get out of hand and have its own tipping point so that we wind up being faced with catastrophe within 100 years. This is known as the Holocene or Helocene extinction. And it's an ongoing extinction event caused by human activity. We're doing this, it's our emissions. We're having an impact on the environment that we're dependent on. So we have to get this thing slowed and stopped of this mass extinction thing. There have been 5 mass extinctions in the history of mankind. The last one was 70 million years ago. 60, 70 million years ago. 75, 80% of all life goes extinct. And that means that we are right now presently on what is called the tipping point of the whole era, the Holocene era. You see this picture? We're on the edge of leaving the Helocene era and into the Helishcene era. We cannot stop this from happening. So we're going to be in new hot waters, if you will. And this is the future. Either it's going to be relatively safe, we can live with it, we're going to survive, or it's going to be very unsafe and hellish. It's going to be early hellish, middle hellish, very hellish. And the Joel Brown view is not worse than early hellish. And to do that, we have to stop losing precious time for making progress in reducing these emissions, slowing them down and getting it stopped. We have an international Paris Agreement since 2015. We withdrew from it in 2017. We got back in. We made some progress. We have been having these intermittent reversing and erasing progress, and it is impossible to be successful since we're the second largest emitter in the world, and other people are following our example to get this slowed and stopped unless we take responsibility. We've got to collaborate together in doing this. We have to work together with every nation, including China, because the two of us amount to about 50% of the world's pollution. We have to be in partnership. On this, we can all agree on survival being important, regardless of our politics. I want you to contact me at your interest and will at climatecliffhanger@gmail.com. I want to suggest Climate Action Handbook by Heidi Roop, United Nations, IPC, and NASA.org for climate newsletter information. And check out sierraclub.org. They're practically in every state. I want to take this opportunity to, as I always do, say this is for my daughters, Robin and Sean, Missy and Christy, my grandchildren Owen B. and Mason, my supportive buddies Jimmy, Greg, Eugene, and Stahl, and of course to my wife, Nancy, loving as they come as a partner. Good luck to you. Go to it.